All right, hello, welcome. Welcome to the only space channel on the internet. It's Matty Adams. So I wanted to go do something a little bit different today, and I wanted to go over some outer space news, some of the news from the last week that we've seen. There were a couple pretty crazy stories that I wanted to get into. Just let me get my phone set up here. Oh my God, stop. All right, there we go. Sorry, I was a minute late. Still getting used to setting everything up here. So, this is very interesting, though. Um, Scientists say so. Obviously, I know that this goes around in the news every couple of years, right? That some sort of life is discovered on Mars, and then it turns out that, it's contaminated or something was wrong with the sample, something was wrong with how the science was analyzed. But this looks to be very, very promising. So, a sample collected by NASA's Perseverance Mars rover from an ancient dry riverbed in the Jezero Crater could preserve evidence of ancient microbial life. Taken from a rock named the Cheyava Falls last year, the sample is called Sapphire Canyon. It contains potential biosignatures according to a paper published on Wednesday by the Nature Journal. So let's check this out. So igneous and sedimentary rocks within the Jezero Crater characterize early Martian geological processes and habitability and search for potential biosignatures. Hold on, let me move this over here. So I know my picture's in the way. Hold on. There, that's better. Okay. So Perseverance investigated distinctive mudstone and conglomerate outcrops of the Bright Angel Formation. So here we report a detailed geological, petrographic, and geochemical survey of these rocks that show organic carbon-bearing mudstones in the Bright Angel Formation contain sub-millimeter scale nodules. And um, so this is let me actually open this in another tab here. But this is essentially what they're looking at here. Let me move my picture out of the way again. So this is essentially what they're looking at here. The Perseverance rover discovered these, what they call leopard spots, on a reddish rock nicknamed the Cheyava Falls in Mars Jezero Crater on July 2024. So this was found in 2024, but as with a lot of kind of outer space stuff, right, they have to actually go through the data. They have to figure out, if it was contaminated, if all of the data is correct. So this finding is a direct result of NASA's effort to strategically plan, develop, and execute a mission able to deliver exactly this type of science, the identification of potential biosignature on Mars, said Nikki Fox. With the publication of this peer-reviewed result, NASA makes the data available to the wider science community for further study to confirm or refute its biological potential. The combination of chemical compounds we found in the Bright Angel Formation could have been a rich source of energy for microbial metabolism, said Perseverance Science Joel Hurwitz of the Stony Brook University in New York and lead author of the paper. I have a friend that went to Stony Brook. But just because we saw all these compelling chemical signatures in the data doesn't mean we had a potential biosignature. We needed to analyze what that data could mean. So that's why we're hearing about this now in September, even though it was in July that this was discovered. So the first to collect data on the rock were Perseverance's Pixel and Sherlock instruments while investigating Cheyava Falls, an arrowhead-shaped rock measuring 3.2 feet by 2 feet. They found what appeared to be colorful spots. And again, so these are the spots that we're looking at here. That's a selfie. This is a little bit more zoomed in. Oh, it's just the same two pictures. Okay. So, in higher resolution images, the instruments found a distinct pattern of minerals arranged into reaction fronts. The points of contact where chemical and physical reactions occur, and the team called them leopard spots. So these spots carried the signature of two iron-rich minerals, vivinite, which is hydrated iron phosphate, and greigite, which is iron sulfide. So vivinite is frequently found on Earth in sediments, peat, and bogs, and around decaying organic matter. Similarly, certain forms of microbial life on Earth can produce this as well. The combination of these minerals, which appear to have formed by electron transfer reactions between the sediment and organic matter, is a potential fingerprint for microbial life, which would use these reactions to produce energy for growth. So these minerals can also be generated abiotically, this is important, or without the presence of life. So hence, there are always ways to produce them without biological reasons, including sustained high temperatures, acidic conditions, and binding by organic compounds. However, the rocks at the Bright Angel do not show evidence that they experience high temperatures or acidic conditions. Again, very important. And it's unknown whether the organic compounds present would have been capable of catalyzing the reaction at low temperatures. So this discovery was particularly surprising because it involves some of the youngest sedimentary rocks the mission has investigated. An earlier hypothesis assumed signs of ancient life would be confined to older rock formations. This finding suggests that Mars could have been habitable for a longer period of time or longer in the planet's history than previously thought. And I don't know about you, but I've pretty much just I think most people at this point, we're pretty sure there was life on Mars at one point, right? But it's about finding that evidence, because it just looks so much like Earth. It looks like an Earth desert. So, um, astrobiological complaints, uh, astrobiological claims, particularly those related to the potential discovery of past extraterrestrial life, require extraordinary evidence. And that's why I didn't want to report on this yet, and I'm always careful reporting on stuff like this because, like I said, you do tend to see an article like this about like once a year, once every 2 years, that there's a potential possibility for life on Mars. So it's always important to really look at it deeply. And realistically, we're not going to know like for sure until these samples probably actually get sent back to Earth. So getting such a significant finding on a potential biosignature into a peer-reviewed publication is a crucial step in the process because it ensures the rigor, validity, and significance of our results. So the scientific community uses tools and frameworks like the cold scale and standards of evidence to assess whether the data released in the search for life actually answers the question. All right, so this is the assessment level they go through. So detection of a signal that's known to result from a biological activity. Level 2 is you have to rule out human or contamination. Level 3, demonstration of prediction of biological production of signal in the environment of detection. Level 4, all known non-biological sources of signal shown to be implausible. Level 5, additional independent signal from the body detected. Level 6, future observations that rule out alternate hypothesis. And Level 7, independent follow-up observations. So this is the amount of scrutiny that it has to go through. And every single time that we've thought we've found life on Mars, it hasn't been able to stand up to this scrutiny. It's always actually been ruled out somewhere between like level 2 and level 5. So Sapphire Canyon is one of 27 rock cores the rover has collected since landing at Jezero Crater in February of 2021. So it's been rocking out there for over 4 years. Among the suite of science instruments is a weather station that provides environmental information for human missions, as well as swatches of spacesuit material, so NASA can study how the spacesuits would fare on Mars. Managed by by Caltech, NASA, and JPL. And by the way, if you watch any of my videos, you will notice that they are pretty much linked with everything. So, from what I've been able to tell, this actually seems really legit. I'm seeing some pretty solid reporters that are really reporting on this, saying that this looks. Hey, I don't want to be too sensationalist, but this looks really, really, really promising. Um, and so, like I said, you see these are the spots that they're talking about here. These little green spots. Um, Still, the findings are not a confirmation of life. With the publication of this peer-reviewed result, it's available for the community to scrutinize. So, and like I said, this is the actual paper in the journal Nature. If you're interested in it, I'll link it when we're done here. So let's see what their conclusion is. Like I said, this is very long. I'm not going to read this entire journal Nature here. But let's just look at the summary. So in summary, our analysis leads us to conclude that the Bright Angel Formation contains textures, chemical and mineral characteristics, and organic signatures that warrant consideration as potential biosignatures. That is a feature that is consistent with biological processes and that, when encountered, challenges the researcher to attribute it either to inanimate or to biological processes, compelling them to gather more data before reaching a conclusion as to the presence or absence of life. This assessment is further supported by the geological context of the Bright Angel Formation, which indicates that it is sedimentary in origin. This is important. They're pretty sure this is a dry riverbed, and deposited from water under habitable conditions. Many significant questions remain about the origin of the nodules and reaction fronts encountered by Perseverance. We suggest that further in-situation laboratory modeling and field analog research into both abiotic and biological processes that give rise to the suite of mineral and organic phases observed in the Bright Angel Formation will improve our understanding of the conditions in which they formed. All right, so what does that all mean? Basically, what that means is it's really promising. It seems like it's a sign of biological life, but we need more research. We need more scrutiny, and we actually need the evidence sent back home, and we need more people to scrutinize it and research it. So very, very promising, not completely sure. Now, this is the really interesting story that I wanted to get into, and I first saw it about a week ago. So let's just take a look. I want to get a look at this video first. So you are going to notice this is a very, very blurry video. So, and this was at a House UFO hearing where this was talked about. So this isn't just some kind of crazy conspiracy website sort of stuff. I hate ads. Why do they got to do that to us, guys? You know what? We're not using CBS. We're going to use something else. All right. So this is the New York Post, but if you don't like the New York Post, there are plenty of other sites that reported on this. This is just a slideshow. I want to get the actual video. Sorry, videos. So I was watching this earlier. So I hate Bing. I'm not going to use Bing. Sorry. So I just want to say, as a little bit of a pretext too, that so I used to work with Patriot missiles in the Army, and so my initial analysis of this is that it was probably just a missile where the warhead didn't go off, and it glanced off of probably a Syrian drone. And why I think that we'll get into in a little bit, but let's take a look at this really blurry, crappy video that's taken from the Predator drone. So you see here, round object being tracked. Now, this is the only reason, with such a blurry image, it's very possible that this is actually a drone and you're just getting a front-on view of it. And so you're not really seeing the wings. But what you see here is that the Hellfire actually hits it, glances off, you see some debris fall, right? But the object itself was not downed and was not found, I guess. So I don't know. It's really hard to tell what's going on in this video. And next week, I think we'll take a look a little bit at the guy's testimony of what he said he saw. But to me, like I said, it's very, very blurry. Now, Avi Loeb, which, if you're familiar with Avi Loeb, he's a little bit sensationalist. He likes to think that things are probably aliens, right? So he is a Harvard professor, or he works for Harvard. But when Oumuamua came through, he said it's probably aliens. When Three Eye Atlas came through, he said it's probably aliens, right? So we're not talking about somebody who is afraid to say this is possibly aliens. In fact, Avi Loeb is, in my opinion, when I've seen him report on things, he tends to lean towards the extraterrestrial side more, right? I don't think there's anything wrong with that. I think we actually need more people like that. But even he said, when he's looking at this, he's like, it looks like the missile is going flying about 6 times faster than the object in question. And you look at the speed of a Hellfire missile, if it's going 6 times faster than the object, that would actually mean that the object is going at about the speed of a Syrian drone. Um, so let me see if that's actually in this article. There's an article I was reading earlier where it's actually talking about Avi Loeb and what he said. Um, I said, very interesting guy, by the way, Avi Loeb. Like I said, when Oumuamua came through, when 3i Atlas came through, he was one of the first people to say, this could definitely, this could quite possibly be extraterrestrial. And he, is oftentimes, I think, called a little bit crazy um, in the scientific community. But like I said, it was a Hellfire missile shot from an MQ-9 Reaper drone towards a UAP, right? And this is your UAP, this is your Hellfire missile. But when you've seen people in these congressional testimonies and they're talking about these kind of pill-shaped UAPs or whatever, they seem to be traveling very, very fast. So the fact that the Hellfire missile is traveling about 6 times faster than the unidentified object in this video does lead me to believe that it's probably a drone. And like I said, I am really into outer space. I used to work with Patriot missiles, so this is actually sort of at the intersection of some of my highest expertise. And, I would just say that, when you're looking at really grainy images like this, you always have to take it with a grain of salt. But like I said, I am interested in listening to the guys. I'm going to kidnap you. I know, Danny. That's what I'm saying too. It's very, very grainy, and everyone's just like, "Oh, it's an orb," and I'm like, "Okay, like, if you know anything about radars, like I say, you could be looking at this thing head on. You're not gonna see the profile of the wings." Um, so yeah, so this is the video that was posted on X originally. So they got the green light to engage. Like I said, very, very blurry. This is the full video actually. So you have one Reaper tracking it, and then the other Reaper is firing the missile. The other Reaper is actually off camera right now. Yeah, just weird, right? But the odd thing is that it keeps flying. So I just wanted to share a little story with you guys. Actually, when I worked in Patriot, I actually got to be part of a live fire where we shot one Patriot missile at another Patriot missile. And obviously, when we do those things, we're using older missiles that are getting ready to be retired. And our our missile actually didn't go off. It was a dud. So even though Hellfire missiles are extremely, extremely good missiles, this is the video from a second Reaper drone, Danny. So there were two Reaper drones. One Reaper drone that's off camera fires the missile. And then that's what's weird is I don't know what these three pieces of debris are. Now, if I had to guess, to me it would seem like, like I said, if this is a drone, the missile glanced off of it, the warhead didn't detonate, and then either some pieces of the missile or some pieces of the drone broke off, right? It could have been a munition that fell off of the drone. It could have been a part of a wing, part of a spoiler, right? Or it could have even just been some of the metal from the missile itself. It's so hard to tell. And then, like I said, just such bad quality on this. And like I said, the only reason why I and other people like Avi Loeb actually think that this isn't extraterrestrial is just because of the speed that it's traveling. When people have said, when we've had these Air Force pilots talking about these pill-shaped UAPs and stuff like that, they say that they're able to accelerate instantaneously with no propulsion, and so they're so fast that our missiles just wouldn't catch up to them. So just a very, very weird video and very interesting, but yeah, just very odd story here. So at the time tag of 20 seconds, it establishes contact with the UAP, breaks off a few small pieces. So evidently it doesn't detonate. But, a lot of people on the internet were going to say, oh, there's like some advanced alien technology that managed to deflect this missile off. I'm like, no, probably not. It was in Syria. It's probably a drone. Now, the interesting thing is that Reaper drones carrying Hellfires generally aren't used for um, air-to-air attacks. But, you're in the area, you see a drone, why not, right? And they have been used for that before, so just very, very interesting. So I'll link all of this in the description when we're done. And I think we'll close out the day by just looking at my favorite sites. Now, when I go to look at web images, go to this one. Go to the actual webtelescope.org. I don't know why they're so bad with their search optimization. Because look, even when you search for Webb Image Archive, you get NASA's first. But I like going to the actual Webb Telescope site, and I will show you why. Um, Observatory. Multimedia images. Here we go. Go to gallery. This is not where I usually go. Hold on. I just want to find the right part. Yeah, it should be right here. Do, do, do. Oh, from September 10th. NASA's Webb observes immense stellar jet on the outskirts of our Milky Way. A blowtorch of seething gases. Oh, let me move this. Bam! I'm over here now. Right. A blowtorch of seething gases erupted from a volcanically growing monster star has been captured by NASA's JWST, stretching across 8 light years. The length of the stellar eruption is approximately twice the distance between our sun and the nearest stars, Alpha Centauri. The size and strength of this particular stellar jet, located in a nebula known as Sharpless 2284, qualifies it as rare. Streaking across space at hundreds of thousands of miles per hour, the outflow resembles a double-bladed dueling lightsaber. Let's take a look. So these are the 8 light year across jets that they're talking about. Wow. Somebody told me when I say that I have to have Owen Wilson pop up every time now. So this is a blowtorch of seething gases. We didn't really know there was a massive star with this kind of superjet out there before the observation. Such a spectacular outflow of molecular hydrogen from a massive star is rare in other regions of our galaxy, said lead author Yu Chang of the National Observatory of Japan. Wow. This unique class of stellar fireworks are highly collimated jets of plasma shooting out from newly forming stars. Such jetted outflows are a star's spectacular birth announcement to the universe. Some of the infalling gas building up around a central star is blasting along the star's spin axis, likely under the influence of magnetic fields. So that is, I believe this is what they're talking about there. Yeah, Danny, everything about the drone was pretty weird. Like I will say the shape of it definitely looks weird when you're looking in the image. It does look to be like a pill shape. Um, Certainly odd. So, maybe next week we'll get into the guy's testimony a little bit. But, the issue that I have, even if you're talking about highly ranked Air Force people, is, especially nowadays, people retire from their jobs and they want to be YouTubers, they want to be famous. So this idea that, like, just because someone's like a high ranking Air Force officer, the idea that they don't understand something really sensational like a UAP could make them famous. You do need to consider that. You do need to consider if people just want clout, if people want, something for themselves. And so when the only evidence that you have is just a very, very grainy video, I think it's important to scrutinize it. Yeah. Yeah, it's crazy. And Danny, I always wonder too, like, And this might sound maybe like something a scientist shouldn't say, but I always wonder if the distances in the universe are just so vast that time and distance actually just don't really allow for interstellar travel. Because let's say we do find a civilization that's 100 million light years away, right? Let's say we finally do manage to get our crap together. All the nations aren't at war. We can actually come together, make some giant interstellar spaceship that's going to make it there. Um, Even if we can manage to travel at the speed of light, it takes us 100 million light years to get there. That civilization could just be completely wiped out by then, right? So it makes you wonder if just the immense time, distance, and scale of the galaxy itself, if it just makes it impossible for interstellar travel, and if we're really just living a pipe dream. Now, obviously, that doesn't mean I'm like, hey, let's stop trying. Um, but yeah, there's just such vast distances out there. It's totally crazy. Like, yeah. NASA's Webb looks at Earth-sized habitable zone. Yeah, so this was interesting too. TRAPPIST-1E, Earth-sized in the habitable zone. Um, so we're in the midst of observing it with NASA's JWST. Careful analysis of the results so far presents several potential scenarios for what the planet's atmosphere and surface may be like, as NASA science missions lay key groundwork to answer the question, are we alone in the universe? Now, the TRAPPIST-1 system is famous because it has several planets in the habitable zone. I think it has the most known planets in the habitable zone. Um, so Webb's infrared instruments are giving us more detail than we've ever had access to before. And the initial 4 observations we've been able to make of planet E are showing us what we have to work with when the rest of the information comes in, said Nestor Espinoza from the Space Telescope Science Institute in Baltimore, principal investigator of the research team. 2 scientific papers detailing the team's initial results are published in the Astrophysical Journal letters. I'm sorry about that noise in the background. My dog has a lung tumor, actually. So, of the 7 Earth-sized worlds, yeah, so there's 7 probably Earth-sized worlds orbiting the red dwarf star of TRAPPIST-1, so that's why it's so very interesting and fascinating to us. So planet E is of particular interest because it orbits the star at a distance where water on the surface is theoretically possible. It's not too hot, not too cold, but only if the planet has an atmosphere. That's where Webb comes in. Researchers aim the telescope's powerful near-infrared spectrograph instrument at the system as the planet E transited. So as it passed in front of the star, we're measuring it with a spectrograph. The starlight passing through the planet's atmosphere, if there is one, will be partially absorbed, and then we can look at the correlating dips in the light spectrum that reach the Webb, and that will tell astronomers what chemicals are found there. It is a tuma, unfortunately, my little puppy. So, and I do remember them saying, yeah, it probably doesn't have a primary atmosphere. Now, keep in mind, the only thing that kind of sucks is the majority of the stars that we see are red dwarfs. We think something like 80%. So a G-type star like our sun is actually more rare in the universe than something like a red dwarf. We know red dwarfs are very common, so we study them a lot. However, the only problem with them is, with them being so much smaller, the planets have to orbit very close to them to be in a habitable zone, which means that any planet within a habitable zone of a red dwarf star is likely tidally locked. So one side of it is going to be facing the star at all times. Besides that, we have other complications like the fact that red dwarfs just launch out more solar flares and more coronal mass ejections. They are just more volatile in general. So we think it's quite possible that, yes, we could have a lot of planets in what we would consider the quote-unquote habitable zone of our star, but that their atmospheres likely would be completely stripped off by stellar radiation, and if not, it would still be tidally locked, so you would probably only have a very small possible habitable zone, which would be in the twilight zone between the dark and the light side. And we actually talked about that a little bit on our last live when we were playing around with Universe Sandbox. I said that little tiny twilight zone between the light side and the dark side, we think it's possible that life could exist. Or, the planet would have to get kind of lucky, right? Maybe have some sort of a collision that would put it into a spin when it should be tidally locked, right? Um, though multiple possibilities remain open for Planet E because only 4 transits have been analyzed so far. The researchers feel confident that the planet still does not have its primary or original atmosphere. It was probably stripped away. Trappist-1 is a very active star with frequent flares, as I was saying before, so it's not surprising to researchers that any hydrogen-helium atmosphere with which the planet may have formed would have been stripped off by stellar radiation, as, again, I was just saying. Sorry to toot my own horn. However, many planets, including Earth, build up a heavier secondary atmosphere after losing their primary atmosphere. And in fact, we're sort of creating our own atmosphere right now, right, with greenhouse gases. Yet researchers say there's an equal chance there's an atmosphere, and the team developed novel approaches working with Webb's data to determine its potential atmosphere. So a world of fewer possibilities. The researchers say it's unlikely that the atmosphere of Trappist-1e is dominated by carbon dioxide. Analogous. I don't know why I'm not pronouncing that right now. Blah, blah, blah. To the thick atmosphere of Venus and the thin atmosphere of Mars. However, the researchers are also careful to note that there are no direct parallels with our solar system. They said a very different star from our sun. So the planetary system around it is also very different, which challenges both our observational and theoretical assumptions. If there's liquid water on Trappist-1e, the researchers say it would be accompanied by a greenhouse effect, in which various gases, particularly carbon dioxide, keep the atmosphere stable and the planet warm. A little greenhouse gas goes a long way, said Lewis, and the measurements do not rule out adequate carbon dioxides to sustain some water on the surface. But it's not looking good. It's looking like it has either a very thin or non-existent atmosphere. So this would be possible because due to the TRAPPIST-1's planet sizes and close orbits to the star, it's thought that they are all tidally locked. Man, I'm good at this. I was just saying this all before I even read it. So this is the wavelengths of light. So this is what they're actually looking at. If you're ever wondering, these are artists' interpretations, right? We have never directly observed a rocky planet. Okay, we've observed some rogue dwarf super Jupiters that are like 15 times the size of Jupiter. And that's it. We don't have telescopes powerful enough to actually directly observe any of these planets. So anytime that you see a rocky exoplanet and it has coloration, it's always going to be an artist's concept, right? So that's what we think it would look like based on this data, right? So I'm not going to act like I know how to analyze light data, so let's move past this. So Espinosa and co-principal investigator Natalie Allen of Johns Hopkins are leading a team that's currently making 15 additional observations of Planet E with an innovative twist. Ooh, what a twist. What are you going to do, M. Night? The scientists are timing the observations so that Webb catches both planets B and E transiting, one right after another. Oh, that's actually pretty cool. After previous Webb observations of planet B, which is the planet orbiting the closest to TRAPPIST-1, scientists are fairly confident that B is a bare rock without an atmosphere. So this means the signals detected during B's transit can be attributed to the star only, so then they can use this as a comparison to E. Because planet E transits at nearly the same time, there will be less complication from the star's variability. Scientists plan to compare the data from both planets, and any indications of chemicals that show up only in planet E's spectrum can be attributed to its atmosphere. So they're just doing a compare and contrast. We're still really at the early stages of learning what kind of amazing science we can do with Webb. It's incredible to measure the details of starlight around Earth-sized planets 40 light years away and learn what it might be like there, if life could be possible there. So this was at MIT, and Anna Glidden led the research on possible atmospheres for Planet E. We're in a new age of exploration. It's very exciting, and it is crazy that, like I said, I think with the JWST we have been able to directly image a super Jupiter, and I think it was a rogue planet. So essentially like a brown dwarf, right? A failed star, but still smaller than the smallest objects we've been able to directly observe before. I don't even know what kind of crazy telescope it would take for us to be able to actually directly observe rocky planets. You know, in, say, the Trappist system. So, that's another limitation that we seriously have and that we really need to think about is, will we ever be able to directly image these planets? Now, I hope so, but we just took a massive, massive telescope that we had to unfold and put outside of the orbit of the moon. We still can't directly image rocky planets, right? So, just something kind of interesting to think about. Um, Man, let's watch that drone video one more time. Just because, like I said, this is interesting because Reapers. That is one of the things that's a little bit suspicious to me is that Reaper drones generally are not used in air-to-air combat. And again, I hate Bing. Who else dislikes Bing? Only reason I use it is because I get Bing points and free Walmart gift cards. And because I work in IT, so I kind of have to use Microsoft projects. Yeah, so like I said, Aviload thinks it's a Samad drone. And like I said, when you're looking at the speeds of it, that tends to track. I would like to think that if super advanced aliens were here and they're flying around looking at us, that Hellfire missile ain't even gonna glance off of them, guys. Let's just be honest. Um, think about the fact that we have nuclear submarines, right, under the water. You're lame. We have nuclear submarines under the water. Russia doesn't know where they are. Russia has nuclear submarines under the water. We don't know where they are, right? So you think an advanced alien civilization is going to be just flying UAPs around and we're going to be able to observe them? I mean, maybe we catch little glimpses of them, but I mean, I think if they're here, we're probably not going to find them until they want to be found. And maybe that is where we're at now. Yeah, and so this is not. Hold on. I'm gonna go to this. Not NASA, not NASA. Yeah, webtelescope.org. There we go. Images 2024. Let's see, search images. Oh, they've changed the search filter here. Because I generally, when I'm looking for images, I only want to see direct images. I don't really care about the artist's interpretations. They're cool and everything, but oh man, check this out. NGC 6072 NIRCam. JWST's view of planetary nebula NGC. NGC is just a naming catalog, by the way, guys. So if you ever see this, if you ever wonder why some nebula, some galaxies will have a cool name, like the Butterfly Nebula or the Hummingbird Nebula or something like that. But because there's so many objects out there, we just have like a galactic catalog and they're numbered, just to limit confusion. So you will notice that some nebulas, some galaxies will have, like I said, kind of a cool, more unique name, and then they'll also have an NGC name too. So if you're ever wondering what that is, it's just because there's so many objects out there. So it shows a complex scene of multiple outflows expanding at different angles from a dying star at the center of the scene. There's one stretching from roughly 11 to 5 o'clock, another from 11 to 7 o'clock, and possibly a third from 12 to 6 o'clock. So outflow, 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 outflow. I suspect there's at least one other star interacting with the material cast off by the central dying star right here. Man, beautiful. It's in Scorpius. Only 3,300 light years away, though, guys. So if we discovered life there, we hurry up and get a ship together, we might get there quick enough for them to be extinct. I'm going to build a giant radio telescope array on the dark side of the moon since it would block out radio waves from the Earth and the Sun. Yeah, that makes sense. The reason why uh, the Webb actually orbits outside of the moon already. So I think it's in the L2 Lagrange point. Um, so here, the moon is 384,000 kilometers away. Webb orbits at 1.5 million kilometers away. So that's a big part of the reason why we make space telescopes. Now, as far as you're talking about with blocking out radio waves from the Earth and stuff, it might not do that. Um, but it's so far away from Earth that we don't have to worry about the light pollution from the Earth anymore. So it took roughly 30 days for Webb to reach the start of its orbit at L2, but only 3 days to get as far away as the moon's orbit, which is about a quarter of the way there. Getting it around its L2 is like reaching the top of a hill by pedaling a bicycle vigorously only at the very beginning of the climb, generating enough energy and speed to spend most of the way coasting up the hill so as to slow to a stop and barely arrive at the top. So Webb is orbiting the sun further out than Earth. Shouldn't it take more than a year to orbit the sun? Normally, yes, but the balance of this combined with gravitational pull of the sun and the Earth at the L2 point means that it keeps up with the Earth as it goes around the sun. So that's what these different Lagrange points are. They are just points where things can have a nice stable orbit with relatively little correction. So it doesn't sit stationary precisely at L2. It's actually similar in size to the moon's orbits around the Earth. So it keeps it out of the shadows of both the Earth and the moon, unlike Hubble, which goes in and out of the Earth's shadow every 90 minutes. So, Hubble orbits pretty far out, but it's still getting shadowed by the Earth. So Joseph Lagrange was an 18th century mathematician. He found a solution to what was called the three-body problem. That is, if there's any stable configuration in which three bodies could orbit each other yet stay in the same position relative to each other. There are 5 solutions to this problem: L1, L2, L3, L4, and L5. The gravitational pull of 2 large masses precisely equals the centripetal force required for a small object to move with them. So L1, L2, and L3 are all in line with each other. And then L4 and L5 are the points of the equilateral triangle. See, this is why you have to pay attention to math in school, kids. So it's easy for an object at one of these 5 points to stay in place relative to the other 2 bodies. L4 and L5 are stable in that the objects will orbit L4 and L5 with no assistance. Some small asteroids are known to be orbiting the Sun, Earth, and L4 and L5 points. However, L1, L2, and L3 are metastable, so objects around these points slowly drift away into their own orbits. So L1, L2, and L3 aren't perfect. We need to do like little jet bursts occasionally just to keep the Webb in that L2 point. So, but yeah, that's the Webb stuff. So I think that's it for today, guys. I'm going to get out of here. I'm going to cut out some of the more fun stuff, make it into a shorter video for you tomorrow, and then I'll make sure to link all of this stuff in the description, so make sure to check that out. And then let me know in the comments, what do you think? Is there life on Mars? Do they always just sort of find stuff like this and throw it in the news to get people excited? I think this one's actually really promising. And then let me know what you think about the alleged drone shoot down. Is it just, again, more sensationalism? Is it just a really blurry radar image? I mean, that's what I think. That's what a lot of people think. Or is it, an alien orb that managed to evade a Hellfire missile? Let me know what you think. Let me know in the comments what other kind of news that you're interested in next week. Like I said, trying something new here, so let me know if this is something that interested you guys. I appreciate you for hanging out with me, and I hope you learned something new today. Thanks for checking out the